Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Divani from Department of Computer Science, Arabic College, University of Delhi. So in the previous lecture of our this series programming in Java, we have seen array concept of arrays in Java, and that too we have seen specifically we targeted one dimensional array. So here in this lecture we will be looking into multi-dimensional arrays, and then later on we will be looking into further topics. So in Java or generally speaking, multi-dimensional array when I am talking about is actually an array of arrays, but in Java it could be a regular multi-dimensional array or it could be an irregular multi-dimensional array. I will be elaborating the concept. First let us have a look at this multi-dimensional array. So in order to declare a multi-dimensional array variable, please mind it, here I am saying in order to declare a multi-dimensional array variable, because through this I am just declaring it and we have not instantiated it yet. So in order to declare a multi-dimensional array variable, we need to specify one more index. If I am talking about a 2D array using another set of square brackets. So basically the name of the array here is 2D, and the type here is integer. So the syntax goes like this, int 2D, then one set of square brackets followed by another set of square brackets. These two set of square brackets are giving you the idea that this is actually a multi-dimensional array in which the total number of dimensions is 2 and is equals to new int 4, 5. So within the first bracket I have taken 4 and within the second bracket I have written 5. So this 4 by 5 is actually the size of that two-dimensional array. Using this, this is going to declare a 4 by 5 array, and that 4 by 5 array is referred here with the name of 2D. Now how this 4 by 5 array is going to look? So 4 rows, 0th row, first row, second row and third row, and 5 columns, 0 column, column number 1, then column number 2, column number 3, column number 4. I am sure that you are all familiar with this type of arrays. So here the left index determines the rows. So the left index 0, 1, 2, 3 in all the rows. Then if you can see the second element, which is to the right of the cornermost first element, that is saying 0, 1. So the index or the we can say positioning of that particular cell is 0th row first column, then followed by 0th row second column, 0th row third column, 0th row fourth column, and so on and so forth. So left index is determining the row, and right index is actually determining the column, and the size of this array is nothing but 4 cross 5. So 4 rows and 5 columns. So 4 rows is starting from 0 going till 3, and 5 is starting from columns is starting from 0 going till 4. Now that is one way of kind of I can say creation of this array. There is also an kind of an alternate array. In order to allocate memory for a multi-dimensional array, we need to determine the memory for the first dimension initially, and we can allocate the remaining dimensions separately. So the alternate way of that particular declaration goes like this. This says integer 2D followed by two sets of brackets is equals to new integer 4 and followed by a blank I can say followed by a blank square bracket. So what does it mean? So this essentially means that this is the first dimension of array is being created, or I can say it is declared, and further the second dimensions are created manually. So in that says 2D, the 0th row is new integer 5, then the first row, which is referred as 2D within the bracket 1, is equals to new integer 5. That means that row is also having 5 components. Similar for row number 2 and row number 3. So row number 0, row number 1, row number 2, row number 3, all are having, you know, 5, I can say, 5 elements. That means 5 columns are there. Now one must be wondering that what is the need of, you know, doing it this way. The earlier way in which we were saying integer 2d and we were, you know, specifying the number of rows as well as the number of columns, you know, together. That was also a kind of, you know, I can say fine way. Why we are going into this situation when we are allocating the second dimension manually. So here comes the concept of irregular arrays. So multidimensional array, which we have seen this till this point, for example, an array of 4 cross 5. So every row is having, you know, 5 elements. So that's a, I can say, regular array, that's a standard array. In Java, you can have irregular arrays also. That means you need not to allocate the same number of elements for each row or for each dimension. And length of each array is, it could be different, that is, you know, entirely up to you. In order to create a two-dimensional array in which the sizes of the second dimension are unequal, we will be using this particular, you know, we can say technique in which the first dimension is, you know, specified when it is declared, and the second dimension is going to be specified, you know, manually. So here the manual allocation of different size of second dimension will go like this. So within a class, obviously we are going to, you know, have our main function, and within the main function you have, you know, allocated the memory by using new. So integer 2d is equals to new int 4, and we have not specified the second, you know, the size of the second dimension, because size of the second dimension I'm going to make, you know, or I'm going to have it different for different, we can say, rows. So 2d, the 0th row is having only one element. 2d first row will be having 2 elements. 2d third row is having 3 elements, and the 4th row is having 4 elements. So 0th row, first one is having 1 element only, second one is having 2 elements, third one is having 3 elements, and 4th one is also having 4 elements. So, you know, what kind of array this is going to generate? So in order to understand the concept, let us have a look at the screen. So here in this, the first row is having only one element, and that is, you know, I can say denoted, or that element is having an index 0, 0, 0th row, 0th column, no other element within this row. Coming to the next row, which is the row number 1 or row indexed as 1, it is having 2 elements, one is 0, another one is 1, and the index goes like 1, 0, 1, 1, and then for the third row we are having 3 elements, 0th element, first element, second element, and similarly for, you know, we can say for the 4th row it is having 4 elements, 0th, then first, second, and then third. So this type of irregular array is also possible, you know, to be created in Java, and that's, I can say, a very peculiar feature of declaration of, or, you know, kind of permission of this irregular arrays. Now let us see, you know, how are we going to, you know, kind of, we can say, manipulate this or how are we going to access this array. So we have taken 3 variables, I, j and k. K here is equals to 0. For I is equals to 0, I less than 4. That means I am talking about the rows 0, 1, 2 and 3. For j is equals to 0, j less than I plus 1. Now please remember, when I is equals to 0, we are having 1 element. When I is equals to 1, we are having 2 elements. So the number of, you know, columns or the number of elements in a particular row which are being represented here by using the variable j, that goes from 0 to I plus 1, and 2d of I comma j is equals to k. So the first element 0 will be stored. Then when you execute these two loops, you will come to the second row that says and after this storing the value of k in 2 of the I comma j, it is going to increment the value of k. So now value of k is 1. So 1 and 2, the two elements will be stored in the second row. Then 3, 4, 5 in the third row, and 6, 7, 8, 9 in the I can say last row. So this will be the output which is being generated by the previous code, I can say. 0, the first 0 will be the element into the first array, first cell of first row. That's the only cell which is present there. Then the two cells inside the first row, 1 and 2, the three cells inside the third row, which is 3, 4, 5, followed by 6, 7, 8, 9 in the last row. Now one must be wondering that why such a facility of creation of irregular arrays is being permitted here, or what could be the actual application scenario in which these irregular arrays are going to be used. So only kind of we can there could be multiple situations in which these irregular arrays could be very, very useful. One such scenario is if we need a two-dimensional array that is sparsely populated. So for example, we are dealing with a real life application in which we have a data in the form of 2D array, and maybe first row is having 7 elements, and second row is having only 1 element, then third row is having 3 elements, and then so on and so forth. And one let's say the row number 5 is having 100 elements. So it is not a sensible idea to allocate a memory of 5 cross 100 for this particular array, when in all other lines except line number 5 or except row number 5, you actually don't need that much of elements within an row. In one of the rows it could be only 5 elements, in another row it could be 3 elements. So a 2D array that is sparsely populated using an irregular array concept for implementation of this 2D array which is sparsely populated could be a very, very perfect solution when we talk about saving the memory. Now till this point what we have seen is multidimensional array, how this multidimensional array are going to be declared and created in when we talk about the programming concepts of Java. Also we have seen the regular arrays as well as irregular arrays, and within the irregular arrays we have also seen what could be the application scenario. Now from this onwards we are going to take up the next topic, which is about operators in Java. I'll be I can say quickly going through this topic because I'm sure that you all must be aware of all these operators till this point. Now what actually an operator is, if I'm talking about that symbols used for performing some specific operations in Java, those symbols are named as, or those symbols are called as operators. What kind of operators are there when we talk about Java? So here is a list of the operators. So first is the arithmetic operator. Second, we have unary operators. We will be covering all these in a short while. So arithmetic operators, then we have unary operators, then we have assignment operator, relational, logical operator, ternary operator, some bitwise operators, shift operators, and last but not the least is instance of operator. So let us begin with arithmetic operators, the most trivial ones used to perform simple arithmetic operations. on primitive data types. If we want to take them up for non-primitive data types, we need to, do some special kind of programming. So arithmetic operators are used to perform simple arithmetic operations on primitive data types, and these are multiplication, division, modulo, addition, subtraction. I am sure you all must be aware of this. Modulo is going to give you remainder. So, for example, 10 mod 3 is going to give you 1. So, that is what your arithmetic operators are. So, very trivial here. When we come to our next category, which is unary operators, unary operator, as the name indicates, it needs only one operand. Now, one operand that it can be used to in order to increment a value, in order to decrement a value, in order to negate a value. So, when we talk about unary minus is used for negating the value. So, 5 is a positive number. If I am going to write it as minus 5, that means I have prefixed this 5 using unary minus, and now the number is negative. We have negated that value. Then we have unary plus, which indicates a positive value. Numbers are, otherwise also the numbers are taken as positive. So, we need not to specify unary plus explicitly. Now, here it performs an automatic conversion to int when the type of its operand is the byte, character or short. If we are going to write unary, plus, or we are going to type that operator in front or in front of a variable, it is going to perform the automatic conversion to integer type. For example, I have written plus a, and a is of type either the byte or character or short. Then after this plus a, that a will be automatically converted to int, and this is what you call unary numeric promotion. Then apart from unary minus or and unary plus, we have plus plus, which is known as increment operator, used for incrementing the value of the variable with which it is being used by 1. Two varieties of increment operators. One is the post increment, that means the value is first used, value of the variables is first used for computing the result and then incremented, and pre-increment is kind of, we can say, opposite of it, in which the value is incremented first and then the result is computed. So, two versions of increment operator, post increment and pre-increment. Similarly, or likewise, we have decrement operator also, which is denoted by two minus signs, and this is used for decrementing the value by 1. Again same two versions or two varieties of decrement operators. One is post decrement, that says value is used first for computing the result and then decremented after computation, and pre-decrement says the value is decremented first and then the result is computed. So, in unary operators we have seen unary plus, unary minus, then we have increment operator, the two versions, post increment, pre increment. Similarly, the decrement operators with its post increment and pre increment versions. Apart from this, one more unary operator is present, which is denoted by exclamation sign, and this is known as logical not operator. This is used for inverting a boolean value. So, for example, I am having a boolean value a, and the value which is stored inside this a is true. Now, if we want to negate it, so I will be writing this logical not operator, which is nothing but an exclamation sign. So, exclamation sign a will give the value of false to a. Coming to the next, which is assignment operator, you all are aware that it's used to assign a value to any variable, and the associativity is right to left. So, right to left says the right hand side value, whatever is being written on the right hand side of your is equals to, that value must be declared before using it, or it should be a constant, or I can say if there is an expression on the right side of equals to, then that expression has to be calculated and the value will be stored inside the variable which is written on the left of equals to sign. So, the general format of this assignment operator is variable equals to value. Now, this can be combined. Now, this equals to operator can be combined with other operators in order to make a compound statement, or in order to build a shorter version of the statement. So, for example, if we want to write a is equals to a plus 5, we can write a plus equals to 5. That is going to give you the same effect as that of a is equals to a plus 5. Similarly, this assignment operator can also be combined not only with the plus, it can be combined with minus, it can be combined with multiplication, division, or even with modulo. So, plus is equals to, it will be used for adding the left operand with the right operand and then assigning the value, calculated value to the variable on the left. So, instead of writing a is equals to a plus 5, we will be writing a plus equals to 5. So, a plus 5 will be calculated and final value will be stored in a. Similarly, minus equals to used for subtracting the right operand from the left operand and then assigning it to the variable. This can be used in the case of a is equals to a minus 5. So, straight we can say a minus equals to 5. Then we have multiplication, division and modulo for the same, likewise I can say. So, for multiplying the left operand with the right and then assigning the value to the variable on the left, we will be using asterisk equals to a is equals to a asterisk 5, or we can write a asterisk equals to 5. A is equals to a divided by 5, we will be writing a divide equals to 5, that is for dividing the left operand by the right operand and thus assigning it to the variable on the left. And similarly, we can do it in the similar manner, we will be doing it for the, we can say, your modulo operator, that is for assigning the modulo to the left operand by the right operand and then assigning the value to the variable on the left. Now, in this series of operators, till this point we have seen our arithmetic operators, we have also seen unary operators, and we have seen the assignment operator. Coming in the further discussions, we have relational operators also, which is used to check for the relations like equality, greater than, less than, and they are always going to return the Boolean results after the comparison. Extensively used in looping statements as well as the conditional if statements, and the general format is variable, then the relational operator and value. So, some of the relational operators are equals to, that is 2 times assignment operator, that is pronounced as equals to. It is going to return true if the left hand side is equals to the right hand side. Then not equals to, that means equals to combined with a logical not. Return true if the left hand side is not equals to the right hand side. Then we have less than, the symbol of the less than is trivial, returns true if the left hand side is less than the right hand side. Similarly, we have less than or equals to, will return true if the left hand side is less than or equals to the right hand side. On the similar lines, we have greater than or equals to, and this was the 6 relational operators: equals to, not equals to, less than equals to, greater than equals to, and they are kind of very frequently used very extensively used in looping statements as well as conditional statements. Apart from that, we have logical operators also. So, logical operators are used to perform logical AND, logical OR operations. These operations are similar to AND gate and OR gate in digital electronics. So, we have logical AND, we have logical OR, and we also have a logical NOT here. Then in the list is the ternary operator, shorthand version of if-else statement. Ternary operator, as the name indicates, 3 operands are there and hence the name ternary. The general format is we need to write a condition then we are going to put a question mark. If this condition is going to be true, then the true block will be executed, which is returned just after the question mark, and if this condition is returning false, the false statement or the false block will be executed, which is returned after the colon. So, condition will be evaluated depending upon the result of the condition, either the true or the false situation is, false block is being executed. We are still left with some, bitwise operators and shift operators that we will be taking in our, I can say upcoming lecture. Here in this lecture we have started with the concept of operators. We have seen arithmetic operators, then we studied unary operators, assignment operator, followed by relational operators we have also seen, and after relational operators we have seen logical operator and ternary operator. And here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I'll see you in the next lecture. Till then, take care. Goodbye.